y equals mx plus c is an equation that represents a straight line, where m and c are just numbers. All straight lines are in this form, or can be rearranged into this form. The number multiplying x, the m, is known as the gradient of the line. Another word for gradient is slope, so m determines the slope or direction of the line. We work out m by using m equals rise over run. The examples to follow will explain this in more detail. C represents the y-intercept of the line. This is the point where the line crosses the y-axis. So let's consider this line. Let's look at C first. It's the y-intercept, or where the line crosses the y-axis. We can see that's just here, and therefore C is equal to 2. For the gradient m, we need to consider rise over run. If we now consider the line, take a convenient point. The line goes 2 units across and 2 units up. So the run is 2 and the rise is 2. So rise over run is 2 divided by 2, which is equal to 1. So the gradient m is equal to 1. So with m equals 1 and c equals 2, substituting back in gives us y is 1x plus 2. Of course, we wouldn't normally write 1x. We'd write y equals x plus 2. Now consider this line. For the y-intercept, we can see it crosses here. So c is equal to minus 3. We now need to look at the slope, i.e. the rise, divided by the run. Just choose any convenient point. We go across by 1 unit, and if we do that, we find we have to go up by 2 to meet the line again. Therefore the rise is 2 and the run is 1, giving us 2. It doesn't matter how large you choose this triangle. If you went across by 2 units, you'd find you go up by 4, and 4 divided by 2 is also 2. So we've found that the gradient is equal to 2. Substitute these values back into y equals mx plus c, and we have y is equal to 2x. Take away 3. Now consider this line. For the y-intercept, we look for where the line crosses the y-axis. It crosses at 2, so c is equal to 2. For the gradient, we need rise divided by run. Choose any convenient point. The line goes across 2 and down 2. Downwards by 2 is a rise of minus 2. So we have minus 2 divided by 2, which is minus 1. Therefore the gradient is minus 1. Substitute these values back into y equals mx plus c, and we have y is equal to minus 1x plus 2. We wouldn't write minus 1x, we'd write y is minus x plus 2, or possibly even y equals 2 minus x. Now consider this line. We can see it crosses the y-axis here, so c is equal to 4. Now for the gradient, we need rise divided by run. Choose a convenient point. If we go across by 1, we go down by 2. Going down by 2 is a rise of minus 2. Minus 2 divided by 1 is minus 2. So the gradient is minus 2. Substituting these into y equals mx plus c gives y is equal to minus 2x plus 4. In the previous examples, we had some lines which sloped upwards and some which sloped downwards. Let's note the differences between positive and negative gradients. Here we have a positive gradient. It slopes from bottom left to top right. If we look at the angle it makes with the x-axis, it's an acute angle. Here we have a negative gradient, which slopes from top left to bottom right. If we look at the angle with the x-axis, we can see that this is an obtuse angle.